Okay, so we're going to start chapter 12 in our volume 2 student textbook. You want to open it up to page 704 here. So you might want to pause the video and then open up to 704. We're going to talk about polynomials. We've already done polynomials already. If you look right here, it says ax plus b is a polynomial. Hopefully you recognize that as a linear function. And then ax squared plus bx plus c is also considered a polynomial. It's a group of expressions. So a polynomial is a mathematical expression involving sums of power in one or more variables multiplied by coefficients. That's pretty important. A polynomial is a one variable and sum of terms in the form of a to the x power. This is important. It's a to the x power, and the x or the k must be a positive exponent. See, it says k is a non-negative integer. Hopefully you remember from several years ago that non-negative integers are all positive integers, but an integer has to be a whole number. So it has to be 0 to infinity, positive numbers, but whole numbers as well. This is sort of an example of a long polynomial. Each one of these things is called a term. And then you know that a is the coefficient in front. So if we look at this bottom, this is a polynomial. We have m to the 3 plus 8m squared minus 10m plus 5 has 4 terms. This right here is term 1. This right here is called term 2. This right here is the third term. And then this right here is the fourth term. So this has 1, 2, 3, 4 terms in this polynomial. Each term is a variable with its product or exponent. So here this has a coefficient of 1. The variable is m, and the power is to the third. And then it's a polynomial as long as this exponent is a positive whole number or a non-negative integer. Then they should be separated by pluses and minuses. This is our second term. Again, the coefficient is 8, the variable is m, and then the 2 makes it a polynomial because it's a positive. And then we have a minus, coefficient of 10, variable of m to the 1 power. And then this is your constant. It's 5, there's no variable, or it could be a variable to the 0 power, which means it's times 1. So let's look down at this bottom section here that I want you to work on. It says write each term from the worked example, then identify the power of the coefficient, identify the coefficient, the power, and the exponent. The first term is already done for you. So if we look at the top, the next one, was 8m squared. Okay, so the coefficient here was the number before the variable, so that should be 8. The power is m to the second, and then the exponent is 2. So I want you to go ahead and finish the third and fourth power. Pause the video and finish that. And the next part below it says analyze each polynomial, identify its term and its coefficients. So first we're going to identify the terms. There's 2 of them. So we're going to write terms here. And the 2 terms are negative 2x squared. And the other term is a positive 100x. Then it says identify the coefficients, so we'll write coefficients here. And then if I look at the coefficients, I have a negative 2 and 100. So we'll just write negative 2 and 100. Sorry. So go ahead and pause the video and finish B and C. And the next thing talks about whether things are a binomial, monomial, or a trinomial. Mono means 1, so it means it would just have 1 term here. So like if you just had 2x squared. A binomial has 2 terms, which would be like our linear equations. If we had 2x plus 5, that would be 2 terms. And a polynomial would be just like the quadratics that we did, like 2x squared plus 3x plus 5. So we could say, a monomial could be just a number or a number with a variable. A binomial should have 2 terms, and a trinomial should have 3. And then you talk about the degree of the polynomial. It's the highest exponent you see in the polynomial. So here, if we look at this one, this has an exponent of 1, and this doesn't have a variable, so the degree of this term would be 1. If we had something such as a quadratic formula, the highest exponent would be x squared, so that would have a degree of 2. So down here, number 3, it says look at it. It has a degree of 1. Khalil says it's a degree of 1 because it's the highest exponent. It says Desmond disagrees that it's a polynomial at all. Explain your answer. Well, hopefully looking through this, you see this has a negative exponent. And back on the previous page, it said our k, or our exponents, had to be a positive whole number. So this is not a polynomial at all. There are 3 terms, but this right here makes this not a polynomial, having that negative number there. So let's look at 4 here. 4 wants you to explain whether these are not polynomials. Going back quite a while ago, we learned that if you wanted to take this and bring it up, it switched its signs. Right now it's 4 over x to the 1 power. I could change this to 4 to the x, and then when you bring it up, it changes it to negative 1. So this makes it not a polynomial because it's a negative. And then back with our square root days, we learned that the square root is something to the 2nd power. So we could change this to x to a half. That's equivalent to the square root of x. And again, that's what we did with radical signs. And so again, this gives you an exponent that's not an integer. It has to be a whole number, and a half is, part of a number. So that would make this not a polynomial as well. And the last thing I want you to do is I want you to turn to page 707. It looks like this. It says number 5, cut each polynomial out. What I want you to do is cut each one of these polynomials out and have them in a baggie or paper clip for class tomorrow. So the rest of your homework is just to have these cut out. If you have a glue stick, that would be great. If not, I'll have them at school for you. So you should have the first 2 pages completed, and you better come in with these cut out or off with your head.